Hello and welcome. Today we are going to be working through problems 8, 9, and 10 on our homework about speed and velocity. Now the first thing to notice, this one has a graph, and we always, when we're given a graph, need to notice what kind of graph it is. In this case, this is a velocity versus time graph. Now let's see, with our velocity versus time graph, that means that that what these points are showing us is not the position, it is the velocity. It's how fast the object is going. Now in this case, the slope of the velocity versus time graph is the change in velocity divided by the change in time, and that is equal to the acceleration. And the area is equal to the velocity times the time, which is equal to the displacement. And this is going to be the idea that is going to be key for our problem here today, is using the area. All right, so let's go ahead and get started. It says, consider a plot below describing the motion along a straight line with an initial position of x naught equals 10 meters. This little notation, x at time 0 or x naught, means that when the item is starting right here at time 0, it is already 10 meters away from the origin. So we'll need to add 10 to whatever our answer is for for question 8. And it says, what is the position at 2 seconds? Now, if this were a position time graph, we would just look at the point. That is not what we're going to do in this case. What we need to do in this case is we need to determine how far it has been displaced. So, displacement in 2 seconds? Question mark? Okay, so how far has it been displaced in 2 seconds? So what we need to do is we need to find the area. I'm just going to shade that area in green. Okay, and so this area right here, the area between the graph and the axis up to 2 seconds. And so the green area, value of the green area is what's equal to our displacement. So we just need to find that. Now that's in the shape of a triangle. The area of a triangle is 1/2 times the base length times the height. And so in this case, we're just going to say, okay, 1/2 times our base length is 2 and our height is 1. So 1/2 times 2 times 1 equals our area. Now in this case, 1/2 times 2 is 1, and then times 1 is 1. So that is equal to 1. So the item has been displaced 1 meter. Now remember though that it started 10 meters away from the origin. So 1 meter plus 10 meters means that the answer to number 8 in this case is 11 meters. So its position is at the 11 meter mark at 2 seconds. That is actually our answer to number 8. So there we have our answer in a box, and that is the answer to number 8. At this point then, let's switch to a red pen and talk about number 9. So number 9 says, what is the position at 6 seconds? Well, at 2 seconds, it was at 2 seconds, it was 11 meters. So we really just need to know how far does it go between 2 seconds and 6 seconds. And so in this case, we're going to find the area of this rectangle and then add the area of this triangle. Okay, so the area of the rectangle added to the area of the triangle will be how much further. So the red area tells us how much it has been displaced, how much displacement between 2 seconds and 6 seconds. And then we'll add that to 11, which is how far it had been displaced at 2 seconds, and then we'll have our answer. So our red area is how much displacement there is. Okay, so the rectangle is length times width. So the rectangle is 1 tall and 1, 2, 3, 4 wide. And then 1/2 times base times height. 1/2 times, my base is 4. And then my height is 1, 2, 3, 4, 5, 6, 7 high. You'll notice that it's at velocity 8, but we started at velocity 1 with this triangle base. And so, so 1/2 times 4 times 7. Now let's see. 1/2 times 4 is 2, times 7 is 14. So 4 plus 14 is 18 meters. 18 meters more. So I'll take, so its position then will be 6 seconds will be 18 meters plus 11 meters for a grand total of 29 meters. All right, so 18 meters plus 11 meters gives us 29 meters, and that is going to equal our, let's just leave that right there. Here we go. And that will equal our position at 6 seconds. All right, you can see how this is going to work. For number 10, it wants to know the position at 8 seconds, and so we need to combine 29 meters, which was the position at 6 seconds, with how far it travels with how far it travels in the next 2 seconds. However, there are two very confusing items that are going to be important for this next question. All right, I'm going to clear off a little bit of space for us here to work. Let's see, actually, let's see, I bet we can work in this little bit of space remaining. Let's switch to our orange pen and we'll just work in this little area right here. So, two concerns. Number one, we need this area that I'm now shading in with the orange pen. All right. However, notice that the velocity is now negative. It is headed back toward the origin. Remember that negative just indicates direction, and so it is headed back toward the origin, which means that we are actually losing distance. Okay, so our position is actually going to be less than 29. So what we need to do is we need to take 29 and subtract the orange area. We're actually going to be adding it, and it's going to be a negative value since our y value is negative, but it's easier to talk about it in terms of subtracting that area because the concept of a negative area is difficult for people to grasp. So 29 meters minus the orange area will equal the displacement at 8 seconds. All right, so all we need to do is find the area of this triangle, which is 1/2 times base times height again. This time the base is 2. The height is a little tricky though, because if you look at it, it's in between the 0 and the 1. And you might be tempted to guess and just say, well, it looks like about 1/2. Here's the thing, it's not. And if you put that, you will get it incorrect on your homework. What we need to do is we need to look at the slope. And we can see that it is at a y value of 0 at 6 seconds and 1 at 9 seconds. That means that the slope is actually negative 1/3. Okay, because it goes down 1/3, down 1/3, down 1/3 to finally have dropped a full unit. So at this point, its value is not 1/2, it is negative 2/3 on my problem. So negative 2/3. So I have a height of negative 2/3. Again, that negative is a little hard for people to conceptualize, so we're just going to add it on at the end. So 1/2 times 2 is 1, and then times the negative 2/3 means that my area is 2/3. Again, it's actually negative, but only in terms of the value for combination. So if I take 29 and subtract 2/3, I will have 28 and 1/3, or 28.3333 for the purposes of putting it into your homework value. Now, of course, these are my numbers. You should look at your own values and work it out in the same way. Remember, area is what we're working with displacement and combining those. All right, I hope that was helpful, and let me know if you have additional questions.